The title of today's paper is Comparing the Antibacterial Performance of Chlorination and Electrolysis Post-Treatments in a Hand-Washing Water Recycling System, published in the Water Research X in 2019. Innovative solutions are necessary to enable the decentralized recycling of greywater for applications requiring high-quality water, such as hand washing. While physical barriers such as ultrafiltration membranes effectively prevent the passage of bacteria, and chemical and biological treatments can effectively reduce the carbon content of the treated water, there exists a knowledge gap regarding the application of antibacterial strategies to prevent the growth of harmful bacteria following treatment. In this study, the effluent water from a household-scale greywater treatment system was fed to 7 parallel experimental post-treatment tanks, 3 receiving direct chlorination with free chlorine residuals of 0.2, 1 or 5 mgCl2/L, 3 with chlorine produced through electrolysis at the same residual concentrations, and 1 control with no chlorine added. For increasing concentrations of direct chlorination, the median total cell count, TCC, values were 9 × 104, 2.9 × 104 and 1.8 × 103 cells per milliliter, respectively. Electrolysis treatment produced very similar TCC concentrations, 8.8 × 104, 1.1 × 104 and 2.3 × 103 cells per milliliter. The TCC concentrations were lower than the concentration of the water entering each tank, 3 × 105 cells per milliliter. Intact cell count, ICC, measurements indicated that the viable cell concentrations were less than 10% of the TCC values. Though electrolysis treatment can produce powerful oxidants, such as hydroxyl radical, there was no evidence that electrolysis in this system provided additional benefits beyond chlorine production for control of total or intact cell counts. Oxidation of bacteria by chlorine was the dominant antibacterial mechanism in our system. Monitoring of dissolved organic carbon, DOC, and assimilable organic carbon, AOC, did not suggest that carbon limitation significantly impacted cell counts when chlorination or electrolysis treatment was applied. This work demonstrates that either direct chlorination or electrolysis treatment are able to reduce bacteria concentrations over long-term operation of a hand-washing water treatment system. We recommend selecting chlorine residual targets such that a chlorine residual is maintained during periods of challenging operating conditions. We observed that a target residual of 1 mgCl2/L in our system maintained the TCC below the concentration found in Zürich drinking water.